Okay, so welcome to another video. So this will be a continuation of what vectors. Okay, so let's just dive right into this short video. Okay, so in case you are new here, kindly subscribe. Okay, subscribe and then hit on the bell icon so that you don't miss out on any uploaded videos. Okay, so now let's move on. Okay, so now in case you've been given what two vectors, okay, maybe vector A has been given as what a1, okay, a2, a3, okay, and then B has been given as what b1, b2, and what b3, okay, and you are told to find what the dot product, okay, dot product. This is how you represent your dot product, okay. So this is how you write a formula, okay. So you have what a1, okay, a2, a3, okay, dot, okay, b1, b2, okay, and then b3, okay. So this is how you write for what your dot product, and this is how you solve for it. So you have what a1, b1, so you are multiplying and then you are adding, okay, a1 multiplied by b1 plus what a2 multiplied by b2 and then plus what a3 multiplied by b3. Now let's move on. Let's use what figures. Let's use numbers, okay. So in case you've been given what vector 2 what 4 and then what vector 3 what minus 1, and you are told to find what their dot product, okay. So this is how their dot product will look like. So we have what 2, 4, okay, dot what 3 minus 1, okay. So this is how it will look like. So we have what 2 times what 3, okay, plus what 4 times what minus 1, okay, and the entire of this one will give us what 2 as the answer, okay. So in case you've been given another example, let's say we have what minus 1, 7, okay, 4, okay, and then we have what another value as what vector as what 6, 2, and then what minus 1 and 2, okay. So this is how you solve for it. So we have what minus 1 times what 6, so we have what minus 1 times 6 plus 7 times what 2, okay, so we have 7 times 2, then plus what 4 times what minus 1 and 2, 4 times minus 1 and 2, okay. So when you do the calculation, when you sum all of this up, you will end up with what 6, okay. Now let's move on, okay. So in case you meet if, okay, so let's say if theta, okay, so we are introducing what a certain expression, okay, a certain formula, okay. So let's say if theta is an angle, okay, if theta is an angle, between, if theta is an angle between two vectors, okay, in two vectors, let's say vectors A and B, okay, vectors A and vector B, then what dot product will look like this, okay. Okay, our dot product will look like this expression, okay. Sorry, let me write this in a different color, okay. So let's see. Cos theta, okay, right. So in case you've been given what angles A and B, I want to find what a certain what angle, a vector A and B, and then you want to find the angle between them. Okay, so this is the formula you use, right? So let's keep that in mind. Okay, and then we move on. Right, so let's say you've been given a certain example, and then you have what you've been given what A. Okay, the length of a length of a certain vector A to be what 4. Okay, and then the length of certain vector B to be what 6, and then you've been given what the angle to what pi on what 3, and then you are told to find what the dot product. Okay, so this is how it will look like. So dot product A B will be equal to what the length of A multiplied by the length of what B. Okay, and then by what cos what theta. Okay, so we know length of A to be what 4, length of B to what 6, right? And then we have what cos theta. Okay, multiplied by what cos theta, and theta is what pi on 3. Okay, theta is pi on 3. So when you compute this, when you compute the dot product, you end up with what your answer being what 12. Okay, so now let's move on. Right, let's move on. So there are what some rules you need to follow in what dot products when it comes to vectors. Okay, so there are certain rules you need to follow. So the first one, let's say the first one, we call it what corollary 1. Okay, so let's say you have corollary 1. Okay, corollary 1. Okay, so we state that if what a certain angle theta is between two non-zero vectors. Okay, so if a certain angle theta, okay, is an angle, okay, it's an angle between two non-zero vectors. Okay, non-zero vectors. So when we talk about non-zero vectors are vectors whereby whenever you sum them up, okay, when you take their dot product and then you sum them up, they are not equal to 0. Okay, those are non-zero vectors. Okay, so A and what and B. Okay, then we can just the same what formula. Okay, this same formula we are trying to make what cos theta the subject, just that. Okay, nothing new. Okay, so we make just cos theta the subject, so we have what cos theta being a subject, and that will be equal to what your dot product, okay, divided by what the length of the two vectors. Okay, so this way we have what two vectors which are what non-zero vectors. Okay, vector A and B are non-zero, means that whenever you take their dot product, they are not equal to what 0. Okay, so let's take an example. Okay, let's take an example to augment our study. So let's say we have vector A to what 2 minus 1. Okay, and then we have vector B to what 5 minus what 3 and what 2. So we are supposed to find what the angle between these two vectors. So that's what corollary 1. Okay, finding the angle between two vectors. So let's say we've been given these two vectors, and then we are told to find what the angle between them. That's where we implement this formula. Okay, that's where we implement this formula. Okay, so let's find the angle between them. So first we find what their dot product. Okay, so dot product of this will give us what 2 minus 1. Okay, dot of what 5 minus what 3 and what 2. Okay, so this will give us what 2 by what 5. Okay, plus what 2 by what minus 3. Okay, and plus minus 1 multiplied by what 2. Okay, when you sum all of this up, okay, when you do the calculation and sum all of this up, you end up with your answer being 2. That's the dot product. Now let's move on to what the length of the what vector. Okay, let's find the length of vector A. Okay, so we have 2 squared plus 2 squared and then plus minus 1. This will give us what? When you compute this, you end up with what? 3. Okay, this is our answer for the length of A. Let's look at the length of B. So for the length of B, we have 5 squared plus negative 3 squared and then plus what? 2 squared. Okay, so when you compute this, you end up with what? Root of 14. So now let's try solving for what? Our angle. Okay, so we have cos theta, okay, to be equal to the dot product AB. AB gave us what? 2. Okay, divided by the length of A was what? 3, and the length of B was what? Root of what? 14. Now let's find what? Theta. So finding theta, we can just simply write cos inverse of what? 2 on what? 3 root 14, and then we have our theta, an angle of 84 degrees. Okay, that will be our final answer. Okay, so now let's move on. Okay, so we are moving on to what? We are moving on to perpendicular and what? Orthogonal vectors. Okay, perpendicular and what? Orthogonal vectors. So some vectors could be what? Perpendicular or orthogonal. Okay, it could be perpendicular or orthogonal. Okay, some vectors could be perpendicular or orthogonal. Okay, so whenever two vectors are either perpendicular or orthogonal, their dot product has to be what? 0. Okay, so it means that perpendicular vectors and then orthogonal vectors are non-zero vectors, are not non-zero vectors. Okay, perpendicular or orthogonal vectors are not non-zero vectors. Perpendicular and orthogonal vectors has to be non-zero vectors. Okay, it means that their dot product has to be always equal to what? 0. Okay, so when two vectors are what? Orthogonal or perpendicular, that's when only if their dot product is what? Equal to 0, or the angle in between them is what? Pi on 2. Okay, so for perpendicular or orthogonal vectors, their dot products has to be what? Equal to 0. Okay, or the product, the angle in between them has to be what? Pi on 2. Okay, the angle in between them has to be pi on 2, or their dot product has to be 0. Let's take an example. Okay, so in case you meet a certain example and then you state that maybe show show that let's say 2i plus 2y minus k, okay, 2i plus 2y minus k is perpendicular or orthogonal to 5i minus 4j plus 2k, okay. So the only thing you do is just use your what dot product to verify, okay. Just use your dot product to verify. So we have what 2i plus, okay, let me change the color so that it will be much clearer, okay. So we have what 2i, okay, 2i plus 2j minus k, okay. You just find the dot products so that you verify whether they are what perpendicular or orthogonal, okay. That's what 2k. Now let's see whether they are perpendicular or orthogonal. So 2 by what 5, 2 by 5 plus 2 on what minus 4, okay, and then what we have minus 1, okay. The coefficient of k is minus 1, and then we have what 2k, so by what 2, okay. So when you do this simple mathematics, you will notice the entire of this will give you what 0, okay. So kindly stay with me. There is a gift at the end of the video I'll share with you, okay. Stay with me till the end of the video, and then you get to know that gift, okay. It's a special bonus, okay. So now let's move on to the last and final, okay, subtopic, okay. So we have what vector projections, okay. Vector projections. So when we talk about vector projections, we are trying to project one vector onto the other vector, okay. So let's say we have vector A and then vector B, and you are trying to project one vector onto the other vector. So for vector projections, there are only two formulas you need to know, okay. So just keep those formulas and then you are good to go, okay. So the first formula is what for scalar projections, and then the second one is what for vector projections, okay. For scalar projections, okay, so for scalar projection of vector B on vector A, we have what the formula to be COM. So we have subscript A and then we have superscript B, okay, to be equal to the dot product divided by what the length of the vector A, okay. And then we have for vector projection, okay, for vector projection of vector B on what A, we have what projection, we have proj, and then we have what subscript A and then the superscript what B to be equal to what, let's open a bracket over here, okay. That's the formula, okay. So the formula is what A dot B, okay, the vector dot product, okay, divided by what the length of the vector. So you could notice that the scalar could be found within what the vector, okay. So the entire of this is the same as this, okay, and then you multiply that by what the vector A divided by what the length of the vector A again, okay. So this can be further simplified to be represented in what this format: A dot B divided by what the length of the vector A squared, okay, and then we have what? The vector A, okay. So keep these formulas in mind, okay. You'll be needing them to solve simple questions, okay. We're needing them to solve simple questions, simple vector questions, right? So let's take a few examples and then we call it what? A day. Now let's say we have what? Vector what? A certain vector. Let's say we have an example, okay. So we have to what? Find the scalar and what? Vector projection, okay. Scalar and vector projection of a certain vector B, which is equal to what? 1, 1, 2 onto a certain vector A, okay, which is equal to minus 2, 3, and what? 1, okay. So all you have to do is just implement this formula, okay. So let's first take the scalar projection, okay. So for scalar projection, we have what? Subscript A, subscript what? B to be equal to what? A dot of what? Length of A. So now let's find what? The dot product of what? A, B. So now here comes our the bonus, okay. So did you know that you could find what? Dot product with your calculator, okay. The vector dot product with your calculator. So let's pull up our calculators, okay. Let's pull up our calculators over here now. So let's clear everything out and put our calculator in what? The vector mode. So you click on mode, you choose 8, okay. Now let's choose our first vector 1, okay, vector A. Let's insert our 3 values, okay. So this is our vector A, so let's choose 1, that's, and then insert our 3 values. So we have what? Minus 2, okay, and then we have what? 3, and then what? 1, okay. Then you click on AC, you click on shift vector, that's 5, and then you choose another vector, okay. So let's choose dim, and then you choose what? Another vector 2, okay. 3 values, okay. So you choose 1. So and then you insert what? Vector B, okay. So B is what? 1, 1, and then 2, okay. So now let's find what our vector, our dot product, okay. So for that you click on shift, you click on 5, okay. So when you click on that, it will bring you to this setup, okay. So it will just bring you back to this setup. So that's why I always insist that after inserting your what? Dot product, you click on the AC, okay, and then you click on shift 5, that's our vector, and then from here you can notice that we have what? 70 what? Dots, okay. 70 with dot, your dot product. So now let's choose our 2 vectors and then we implement our dot product. So we have what? Vector A to be what? 3, okay. Vector A to be 3, and then you click on shift 5 and then you choose 7, okay. We have our dot, okay, and then you click on shift 5 and then you choose your second vector, that's B, so that's 4. So when you click on that and you click on answer, you get what? Your dot product to what? 3, okay. Now so you know that our dot product is what? 3 without going through the normal traditional calculation, and then you know, let's find what the length of vector A. Okay, so pull up your calculator and then you find your length of A. So you click on this. Okay, we have what? minus 2, okay, minus 2 squared, okay, plus what? 3 what? Squared, and then plus what? 1 squared, and then you close the bracket, and that will give us what? 3.74. okay, that is 3.74. so we could just clear this one out and then solve the length of the vector in the normal form. Okay, so now we have what? This, and then let's solve this vector in what? The normal form. Okay, squared, okay, plus what? 3 squared, and then plus what? 1 what? Squared. So that will give us what? Root 14, and then root 14 is the same as what? 3.74. okay, so there's no worries over here. Okay, so we have what? Root 14, right? So we have what? Root 14. Okay, so in simple terms, this will be our scalar projection. Okay, so we are done with what? Scalar projection. Let's move on to what? The vector projection. Okay, so for vector projection, we have our formula. Okay, we have this formula. Okay, so we just keep it. So we have what? Our approach with a subscript and a superscript. Okay, to be equal to, let's keep this formula. So you have what? A dot B divided by what? Length of A squared. Okay, and then you have A. Okay, so this will give us what? Let's write this one out. Okay, we know that A dot B is what? 3 from here. So we have what? 3 divided by what? We know that the length of A to what? Root of 14. Okay, root of 14. Then you put this one in what? Bracket, and then you square it just like here in the formula. Okay, and then you introduce your A. Your A is what? This is your A. Okay, this is your A. That's what? minus 2, 3, and then 1. Okay, so we write it in what? I, J, and then K. Okay, so you have what? minus 2I plus what? 3J. Okay, and plus what? K. So once you are through with this, you are just done with the entire solution. We know that this will cancel this root sign out, so we will be left with what? 3 on what? 14, and then we have what? minus 2I plus 3J plus what? 4 plus K. Okay, so now let's multiply this one throughout and then solve it. Okay, so we have what? This multiplying this throughout, we have minus what? 6I on 14, and then we have plus 9 on 14J, and then we have plus 3 on 14K. So you can further simplify this one out. Okay, can further simplify this one out. So let's take 2 goes here, 3, and then 2 goes here, 7. Okay, so we have 3 on 7 I plus what? 9 on 14 J plus 3 on 14 K. Okay, so this brings us to the end of this tutorial video. Hope you understood this entire dot product concept. Okay, tutorial. Okay, so kindly subscribe, like, comment, and share. Leave your respective questions in the comment section below, and then we will respond to them respectively. Thanks for staying with me till the end of the video, and then I will see you in the next one. Kindly note that you can use the calculator to solve your dot product. Okay, in terms of MCQs and then theory questions, you can just solve with the calculator, just like how I introduced or illustrated in the video. Thank you.